This is the first day of Unit 3, Section 3, Complex Numbers, and we are starting in Section 3.2 in the textbook. So first thing we're going to talk about is the imaginary unit. We've been talking a while that there is real numbers, right? We've talked about all real numbers as being a solution, and sometimes our answer was no real solution. And what happens if there's no real solution is there might be an imaginary solution or a complex solution. So the imaginary unit is I, right? So we're going to use I for the imaginary unit, and I is equivalent to the square root of -1, right? So anytime we have the square root of a negative number, I is actually part of that answer. And if I think about the fact that I equals the square root of -1, if I'm doing I squared, then that's the square root of -1 squared. And you know whenever we square a square root, we eliminate the symbols and we're left with whatever's left. So I squared is actually equivalent to -1. If I have I to the third, that's really I squared times I. So if I put -1 in for I squared, now it's -1 times I, or -I. I to the fourth, well, that's like I squared times I squared. So that's -1 times -1, or +1. The ones we're really going to be dealing with the most are the fact that I equals the square root of -1 and that I squared equals -1. All right, those are going to be the two biggies we work with. We don't really care as much about I cubed and I to the fourth. So let's simplify each of these, right? Now I have the square root of a negative number, and now I know that that's really equivalent to an I. So -4 is really -1 times 4. And we just learned that this is I, right? The square root of -1 is I, and then the square root of 4 is 2. Generally speaking, we put the number in front, so my answer here would be 2I. All right, if I look at B, 12 is really -1 times 12, and then I could break 12 further into 4 times 3. So 3 is not going to be able to be touched, right? I don't have a square root of 3 as a rational number. But this is I, and this is 2, so 2I will go out front, and 2I radical 3 would be our answer. All right, let's look at C. I can't distribute a negative, so this negative is actually its own thing. So I'm going to focus on just the number under the radical first. So that's -1 times 36. So this is I, this is 6, and this out front was just a -1. So if I multiply these together, -1 times 6 is -6, and then we have I. All right, and let's look at D. So this is just a regular 2 outside, and it's -54 underneath. So first I'm going to look at it as -1 times 54. And then 54, if I don't know what it is, I'm going to start to find the factors. 1 and 54, 2 and 27. 27 is not a perfect square, right? 3 and, let's see, 18. 18 is not a perfect square. 4 doesn't go in evenly. 5 doesn't go in evenly. 6 and 9. 9 is in fact a perfect square. That's the biggest perfect square we have. So that means this is really written as square root of 9 times square root of 6, with our square root of -1 out front. So I and 3 are 3I, and we keep the square root of 6. And now when I distribute here, not distribute, I should say, when I multiply here, I'm just going to multiply these parts because they're the only like terms, right? This is in a radical, so it can't be touched. So this is going to be 6I times the square root of 6. All right, and those are our answers for those. You're going to go ahead and try the next set, pause it, and I will show the answer. All right, there's our answers for those. All right, so a complex number has a real part and an imaginary part. So standard form of a complex number is written as a plus bi, where a, or the number in front, is the real part, and bi, right, is the imaginary part. If there was no number in front, then it's purely an imaginary number, right? For equivalent complex numbers, if I had a plus bi and c plus di, the real parts would have to be equal, so a and c would have to be the same, and bi and di, the imaginary parts, would have to be equal. So if we have an equation where we know 2x minus 7i equals 10 plus yi, I'm going to focus on the real parts, 2x and 10, and set those equal. Divide by 2, and x is 5. And then I'm going to focus on the imaginary parts. That's a negative 7i equals yi. And my goal is to get y alone. So I'm going to divide by I here, divide by I here. These i's cancel, so I'm left with negative 7 equals y. Okay? You go ahead and try the next two. You could pause it, and I will show the answer. All right, if you got 5, you're good. 6 was trickier. Don't worry as much if you didn't get 6. Should have gotten 5. We could also add or subtract numbers that are in standard form, complex numbers in standard form. We're going to focus on adding together or subtracting the real parts, and then adding together or subtracting the imaginary parts. We're treating them almost like they were binomials or trinomials. We're treating them as polynomials, and we're treating the I right now almost as if it was a variable. So if I combine like terms, 8 plus 5 is 13. Negative I plus 4i is positive 3i. And that's it. That's standard form because the real part came first, and that one's done. Remember, with subtraction, we're going to change the sign of everything in the second set of parentheses, and then it becomes an addition problem. So now I have 7 and negative 3, which is 4. I have negative 6 and positive 6 cancel out. So my answer here is just 4. And in C, I'm only going to change the signs in this. That's negative 2 minus 7i. So now that's a plus. So if I look at my real numbers, I have 13 and negative 2 is 11. If I look at my imaginary numbers, I have negative 7i and positive 5i is negative 2i. And that's my answer. So you go ahead, try these two, pause it, and I will show the answer. All right, so we get 3 plus 6i for the first one, and negative 5 plus 9i for the second. The last thing we're going to do with complex numbers is we're going to multiply them. So again, at the beginning, we're going to treat I as if it was a variable. But the thing I really have to remember is once I'm done, I squared is really negative 1. I should not have I squared in my final answer. So if I do have one, I'm replacing it with a negative 1 and then continuing to simplify. So here, I'm distributing the 4i to both terms. So 4i times negative 6 is negative 24i. 4i times positive I is plus 4i squared, right? I times I is I squared. So now I'm replacing this I squared with a negative 1. So this is really negative 24i plus 4 times negative 1. So this is negative 24i minus 4. And because we want our answer written in standard form, I have to flip these around. So the 4 was negative, so it's negative 4. 24 was negative, minus 24i. And there's my answer for that one. For B, I have a little more to do. We're going to distribute both things. So 9 times negative 4 was negative 36. 9 times 7i was plus 63i. Negative 2i times negative 4 is plus 8i. And negative 2i times positive 7i is negative 14i squared. So I could do a little bit of work before I go and plug that in. So we have negative 36, 63 plus 8 is plus 71i minus 14 times negative 1, right? We're replacing that I squared with negative 1. So this is really negative 36 plus 71i plus 14, right? Negative 14 times negative 1. So now I'll combine my real numbers, negative 36 plus 14, get negative 22 plus 71i. All right, you go ahead, try the last set. You could pause it, and I will show the answers. All right, so here are our answers for these three. If we hadn't have gotten rid of the I squared, this would have been negative 30I squared, but that's negative 30 times negative 1, so that's positive 30. 8I minus I squared is like 8I minus negative 1, or 8I plus 1, so in standard form that's 1 plus 8I. And then this would end up being 15 plus 2I minus I squared, so that's like 15 minus negative 1, or 15 plus 1, 16 plus 2I. And that is our first lesson on complex numbers.